Good morning everyone. Today we are going to discuss class 8 mathematics chapter number 1 rational number. Previous class we discussed about closure property. I just want to revise closure properties for rational number. You know rational number are closed under addition. What is the meaning of closed under addition? Closed under addition, that means if we plus both number, we will get rational number. That is our rational number are closed under addition. For second, you see rational number are under closed multiplication. What is the meaning of multiplication? If we remove here plus and we minus both rational number, we will get the rational number. In mathematics, we write a minus b is equal c. Here, a, b, c are rational number. A, B, C are rational number. That is why we say rational number are under closed multiplication. You see, next is rational number are under closed subtraction. Under closed subtraction, that means if we subtract both number, we will get new number. Sorry, for multiplication, we will apply here multiply sign. We will apply here multiply sign. Both are multiplication sign. Sometimes we give star for multiplication and this is also multiplication sign. So if we multiply both number, we will get new rational number. That is the meaning of rational number are under closed subtraction. But last point, please remember, rational number are not under closed division. What is the meaning of this? If we divide two rational numbers, we will not get new rational number. That is why we say here rational number are not under closed addition. So homework is, you see page number 4 NCERT rational number chapter number 1. Page number 4 you will see there is try this. You fill that table, fill in the blanks in the following table. Okay, it is your homework. Now we move our next property. Our next property is commutative property. First, we will learn what is the meaning of commutative property. You see here, commutative property, communication, that means we will talk each other. Okay, so here communicate both number to each other. You see here, it is the position of first and it is our second number. And just here we reverse the number and we get this is the first position and it is our second position. You see here we just interchange the position of the number. You see first A plus B, B plus C. Okay, I like to see example. Give example. You see, if we plus 2 plus 6, we will get 8. And in that order, if we put 6 here and we write 2 here, we will get 8. That means we get same number 8 is equal 8. You see, here we see the commutative property of plus, or if we want to see for commutative property for the minus number, subtraction number, we will say if we minus both number and if we change the order of both number, we will get same number. Is it true? I think no. Okay. For example, we take just the same example. 2 minus 6 and 6 minus 2. It is the same. Think about it. Okay, you see, 2 is 6. We have 2 mangoes or we have 2 mangoes. We have 2 mangoes, but we want to give 6 mangoes. How many less? 4 mangoes less. 4 mangoes plus we don't have 4 mangoes. How we give to 6 mangoes? It is not possible. That means we will get minus 4 here and here plus 4. It is equal. What do you think? It is equal minus 4 and 4? No, it is not equal. That is why we say commutative property or follow commutative property under closed subtraction or not. You see here, if we communicate both numbers and if we change intersect, we will not get same number. But it is a different matter. We will discuss about it after some time. Okay, now just you see it is for subtraction because we put here subtraction. Okay, it is for plus, that means addition because we put here plus. Or if we want to see commutative property for multiplication, we will apply here multiplication. We will apply here multiplication. Normally you see, if we multiply 2 multiply 6 and 6 multiply 2, we get both same number. 6 2s are also 12 and 2 6 are also 12. So you see here, if we multiply both numbers, it is easily follow our commutative property. But we will see one by one according to number. We will see commutative property for whole number, natural number also if we want to see, no problem. Natural number, mainly integer. After that we will see this for rational number. So commutative property we see all 4 numbers. Like we already discussed about like closure property. We will see for closure property, commutative property also. You see here, this is for multiplication. And at last, we will see if we divide both numbers. So we will say this is for division. This is for division. So you see here and try to find the difference between the addition, subtraction and multiplication. What I want to explain to you. Okay, you see here, if we put here plus, we will say it is under addition or not. After that, if I put here minus, in word we say it is under subtraction or not, according to situation and number. If we multiply form, we will say it is under for multiplication or not, or it is for division or not. But the commutative property for same. That means if we get one number and if we get second number, okay, we will, if we reverse the order of number, we will get same number in any order. In any order. Here we put the sign of multiplication, plus and division. For all, we will check one by one. So you see here, first of all, we will check this for whole number. Whole number. Okay. You see, whole number start with 0 because our smallest whole number is 0. This is a whole number. You see, if we plus both number, we will get same number. What is your thinking? Yes, we will get same number. If we plus 0 plus 5 or 5 plus 0, or if we change order, it will not change our answer. So that is why we say whole number is under addition, or we say another word, addition is commutative. Okay, because they follow this order and they obey this order. That is why we say addition is communicating. Okay, addition is communicating. For minus, we will put here simply minus. And here also we say, you see, for minus, if we put minus here, If we put minus here, you see 0 minus 5, that means minus 5, and 5 minus 0, that means 5. It is not equal. It is not equal. That is why we say subtraction is not communicative. Subtraction is not communicative because they not follow this order. If we interchange both numbers place, we will get different number. Okay. Same thing if we follow for multiplication. If we follow for multiplication, you see here, if we multiply both numbers, 0 is equal 0. And you see 0 is our whole number. 0 is our whole number. That means if we multiply two whole number, we will get new whole number only. We will get new whole number only. That is why we say multiplication. That is why we say multiplication is commutative. Okay, because they follow this rule. You see, if we change this example also, we will get, if we multiply 2 multiplied 20 and we change the place 20 into 2, we will get 40. Okay, this is equal and it is also whole number. So we can say multiplication is commutative. Now we move next for division. For division, you see, here we put division. Okay. You see, for example, if I say 0 divided by 5 is equal 5 divided by 0. That means we are going to say 0 divided 5 and 5 divided by 0. You see, if 0 comes in denominator form, we will say is not defined. Not defined. Okay. It is, we say, not defined. That is why it is not equal also. So, we can say that, you see another example also, 3 divided by 6 and 6 divided by 3. We will get same number. What do you think? No, we will not get same number. Okay, because 3 divided by 6 is different. If we say 3 2s and this is our 2 1s, it is not equal. It is not equal and 1 by 2 is not a whole number. That is why we say communicative choice. Division is, please remember this one. Okay, division is not communicative. Okay, division is not communicative. So you see, for whole number, this. Now we move for integers. Now we move for integers. You see here, if we say integers, we know the family of integers: minus 3, minus 2, minus 1, 0, 1, 2, 3, dot, dot, dot. Okay, for this you see, here also same thing. Okay, if we say a plus b is equal b plus c, so here we want to say a, b, c are rational number. Sorry, integer number. A, b, c is integer. If we are saying this, so here we write a, b is integers. Okay. You see, we plus both number and we change order, we will definitely get, you see, 3 plus 2 is equal to plus minus 3. So we will get minus 1, 2 plus minus minus 3. That means minus 1. That means minus 1. It is followed. So we will say addition is commutative. Addition is commutative. Now we move for negative number. Okay, you see here, if we put here negative mark, what we will get? You see, same situation change. Minus minus plus, that means 3 plus 5 become minus 5 is equal to minus minus. 2 minus minus plus, it will become 3. That is why we say minus 5 and 5. It is not equal. It is not equal. So we say subtraction is not, please remember, subtraction is not commutative. Okay, now we move for multiplication. Same number if we multiply, what we will get? You see, here we put multiply, 3 to the 6 plus minus minus. But here you see 2 into 3 to the 6 minus 3, that means both are equal. So we say that multiplication is commutative for integers. For integers, don't forget this word, okay? For integers. Now we move for our next division. So here you see division. Okay. If we same thing, 3 upon 2 is equal 2 divided by minus 3. We know that it is not equal. It is not equal. That is why we say division is not commutative. Division is not commutative. So it is all about integers number. Now we move for a rational number. Rational number. We know that what is our rational number if we express p by q and q does not equal 0. P and q are integers, so we say this is our rational number if they follow all these conditions. Okay. Now you see for addition. Okay. For addition, you say if we plus both number and if we change place. For example, I say 2 upon 3 plus 3 upon 2 is equal 3 upon 2 plus 2 upon 3. You see, I change same place. This number position is first, but here is the last. Okay, like that we change the condition. Now we will solve this. For LCM, we will get 3 to the 6. If we multiply 2 here, so we will get 4. 3 3 is 9. For same, if we take LCM, we will get 3 to the 6, and here we multiply 3 3 is 9 and 2 to the 4. You see 9 plus 4 is equal 13 divided by 6, and same here 13 divided by 6. So we can say rational number can be added in any order. We will get, they will follow commutative property. That is why we say addition is commutative for rational number also. Okay, you see here, if we put here minus, we will get here 6, 4 minus 9 and 9 minus 4. You see, 4 minus 9, 9 minus 4, we will get minus 5 divided by 6 and 5 divided by 6. It is not equal. It is not equal. That is why we say rational subtraction is not commutative for rational number. You see, commutative property is not follow it for all rational. It is not for whole number also, integers also, and rational number also. Okay. In the same way, they are not follow division rule. They will not follow division rule. Because in simply we say, if we divide also, if we multiply both number, we will get 3 to the 6, 3 to the 6, 3 to the 6, 3 to the 6. It is equal 1 is equal 1. 1 is a rational number. We can say that this another form 1 divided by 1, 1 divided by 1. That is why we say multiplication is commutative. Multiplication is commutative as well as addition also commutative, but it is not follow for subtraction and division. Here also, if we divide both numbers, we will not get same number. It is not a same. It is not same number. If we solve this, we see here. If we solve this, we will get different number. Okay. You see, if we follow this rule or we solve this problem, we will get different number. 4 upon 9 is not equal to 9 upon 4. That is why we say division is not commutative for rational number. Okay. Division is not commutative for rational number. So, what is the conclusion? Commutative properties follow for all. This is follow for whole number, integers and rational number also. And it is follow for rational number, whole number and integers also. But do not follow for division and subtraction both. Division and subtraction. So that is why, so we can say that division and subtraction is not commutative. Okay. Thank you, students. Please note homework. It is homework for you. You will solve NCERT page number 6. Try this. Complete the following table. Please complete this table. Number. Associative property. You see, first we understand what is the meaning of associative property. Okay. For associative property, we take 3 numbers. Okay. It is very simple and interesting property. This property say order is same. Numbers order is same, but we get single first this one and last this one. And here they solve both numbers together. Then they say, people say it will give same number or not. It will give same number or not. So you see, first if we check for plus, so here we put plus. What is the meaning of associative property? Associative property want to say, if we take three number 2, 3, 4, order is same 2, 3, 4. That is why here also ABC, here also ABC. You see, in property, you see first position as well as order of numbers and subtraction, multiplication, what they want to say. So here, associative property said, if we separate this plus 2, if we separate this plus 2 and we solve this two number together first, we solve this together number, we will solve this two numbers together. And here they get different. Here they get pair for 3 and 4, but here they want to make pair 2 and 3. And here also we put plus for addition. Okay, we put plus. So you see here, if we solve this, 2 is our alone number. 2 is our alone. And if we plus 3 plus 4, we will get 7. We will get 7 equal. That means we also put equal. You see here, if we plus 2 plus 3, we will get 5. We will get 5, and this is our alone number plus 4. So here I also write plus 4. Okay, now we solve both number. 7 plus 2 also 9 and 5 plus 4 also 9. So we can say that addition is associative. Addition is associative. Addition is associative. Okay, addition is associative. You see, if we take another example, here we are going to take 5, 6, 7. Here also 5, 6, 7. We make pair first this and second this. You imagine 3 friends is there. First we want to sit 2 ways to talk together, and first 2 one get talk together. Okay, so like that you make interesting. See, plus 5, that means we write plus 5 simply, and we solve plus this bracket. What is the meaning of this bracket? They want to solve this bracket first. This bracket first. So we plus 6 plus 7, it will become 30. Here also you see 6 plus 5 plus 6. That means 11 and plus 7. You see 5 plus 3, 8. That means 13 plus 5, 18. And here also we get 18. Here also we get 18. So we say addition is associative. Addition is associative. This is all our whole number and integers. And associative property follows our rational number also. So this property follow for associative property follow addition for whole number, integers as well as rational numbers. So please do try to solve this. I hope you understand. If you see my previous video, you can understand. If you not, please go to the channel and you will see all this. Okay, now we can say we will solve this problem for minus. That means subtraction. What is the purpose of this? We want to separate both number this and both number this. Okay. If same thing we say, we take 2, 3, 4. Here also 2, 3, 4. But they make them. You see, 2 become 2 minus 3 minus 4. That means minus 1. And here also 2 minus 3. That means minus 1. And here we get minus 4. But here you see minus minus become plus and it will convert minus minus plus, that means it will become plus 1. But here multiplication is not like that. So we will get here 3 and here minus 5. It is not equal. 3 and minus 5. So we can say that subtraction is not associative. For natural number, whole number, integers number, as well as rational number. Okay. If we put here multiply, you can see, if we put here multiply, we will get 2 multiply 3 4s are 12, 3 2s are 6, multiply 4. It will become 2 multiply 12 and 6 multiply 4. So we can say that 24 is equal 24. 6 4s are also 24, this also 24. So multiplication is associative. But if we divide, we will not get same number like earlier. Okay, it is not same. So we can say that division is not associative. So conclusion is this. We can say that associative property, addition is associative, multiplication is associative, but subtraction and division is not. Subtraction and division is not associative. Okay. Thank you, students. Please try these exercise. Sorry, page number 9. Okay, page number 9 in book. There is give more examples so you can see that, and homework for you. See page number. First you see page number 4, 6, and 9. All try these, try. Then you will understand all these properties: closure, associative, and communicative. Thank you. Have a nice day.